in horticulture, and does a lot of cover crop research pertaining to vegetable systems. Has been active in cover crop research for a long time and has his own cover crop website with some decision tools as part of it, which is really useful. So with that, I'll hand it over to you.
All right. Well, thanks very much. And thanks for the opportunity to talk to this group of movers and shakers in the soil health world. It's a great opportunity for me too. So as Joseph said, so I've had a cover crop website decision tool up on the web targeted at New York vegetable growers for over 10 years. We're starting to get more of those decision tools, and I'm working with a Northeast Cover Crop Council. We're getting ready to launch one that covers the whole Northeast, which is pretty challenging. And it's trying to cover every cropping system also. So there's very few generalizations one can make. They're all very specific recommendations there, but that's great developments coming along to support your efforts to increase soil health. So I'm going to talk about some of the soil health metrics that you can get through the soil health tests and thinking about how to improve those numbers or deal with the limitations in soil health that they tell you about and how cover crops can be used there. And if I click in the right window, so I should say that it's really structured around the comprehensive assessment of soil health and the soil health test there. So I've tied all of the cover crop soil health work closely to how things are identified in this particular analysis. There's a lot of different ways to approach soil health, but because a lot of people in New York use the Cornell framework, and because I work with all these people pretty closely, that's worked out well for me. So it's a valuable approach. If you are using a different one, some of the terminology will be different, but the points I'm making are going to stay the same. So soil health parameters that we're thinking about. So I'm skipping the chemical ones here. You can see they cut off at the bottom of the slide, because with the soil health, the things that are new to people are dealing with the physical parameters, and particularly the biological parameters. And so this is what that looks like right out of that guide. So available water capacity that is largely determined by your soil texture, but also how you manage it. Surface hardness, boy, we've gone round and round on what that means on the cover crop group. Is it the tendency to crust because you have poor soils, poor tilth basically? Or is it that you have an actual compaction layer because of the bottom of your disc or the bottom of your planter opener compressing the soil close to the soil surface? So we go back and forth on that. So there's a couple of different definitions there. Subsurface hardness is generally good old plow pan, but some people have soils that are just inherently hard once you get down a little ways. Aggregate stability is the one that tends to be newer to people and that we really look at as something that can be dealt with on a reasonably short term using management goals. So on the biological side, organic matter, total soil organic matter is something that people tend to be familiar with, and also familiar with the idea that they burn it up over the years and it declines over the long term, and that's a bad thing, but there's nothing you can do about it. I think that's the old framework on organic matter. And to a large extent, it's true that a lot of our soils are depleted in organic matter. That's a big problem that we need to address. Moving that organic matter number up again in sort of the decades time frame that we have is a tall order. So it's not an easy, it tells you how bad things are. It doesn't tell you how, whether you're making improvements. So for that, we have things like soil protein, which is your basically organic nitrogen source, soil respiration, which says how many things are alive in there, and the active carbon is basically the fuel for your soil biology. And so they come out of your report. So I've organized them a little bit differently on that slide. But so the ones that I want to talk about today, just to keep this in ones that are fairly easy to deal with and where cover crops make an interesting difference, are the subsurface hardness on the physical side and the soil protein respiration carbon group on the biological side. And for some reason I have aggregate stability in there. So hopefully everybody here knows the difference between bad crumb and good crumbs. So I am just going to, yeah, I have a whole section on that. So I'm going to skip over the aggregate stability because I assume you know a lot about it, but I like this picture. I want people to think about this picture as we go by. This is a buckwheat root. You see the middle of the root there, the outside edge of the root hair. Those are root hairs coming out from it. And you see all of the soil, all the different sizes of soil particles, different kinds of organic matter. There's probably little creatures in there that are hard to identify. And that is aggregate formation. The key thing with this is they washed that root in running water before taking this picture. So all of that is what sticks to the root because it is causing aggregation. That's because the root is pushing out sticky substances that hold those things together and pushing out food for the fungi and bacteria that help stick those together. So aggregate stability, really important. So we can build that. That's going to help with some of the other things. A lot of the action happens in those aggregates. So, but subsurface hardness, what I actually wanted to talk about here. So when you're using cover crops to deal with subsurface hardness, we're really thinking about perforating that hard layer. There used to be a lot of subsoiling, we called it, and running steel very deep and mixing a lot of the soil volume. And what typically would happen is that your compaction layer would show right back up again next time you drove on it or plowed it. So that sort of bulk subsoiling was pretty transient. And what we've seen in recent years in this area is the move to systems like the deep zone tillage, where you're just doing the same slots over and over again, a technique that requires the GPS steering so that you hit the slots again, the same slots over and over again, and that you're not mixing up the whole soil layer, so that you can have really columns of undisturbed soil in your field that allow the many-year process of reducing the hardness, opening up holes with worms, freezing and thawing, other processes that create some macropores in that area. But we still have this subsurface hardness to deal with, and having the roots grow into holes that were created by previous roots, by worms, by what have you, is really helpful. So what do we look for in a cover crop? So one thing we want is high gravitropism. So which direction does a root grow? It grows in the direction that makes the most sense for it at any given moment. And it's the tip of the root that determines where it's going to go next. So it could be wetter or drier. It could be up or down. It could be more nutrient. All kinds of things determine which direction it's going to go. And the ones that are going to be good for subsurface hardness really prioritize down as the important factor. And so radishes are really a classic for this. There's some of the other brassica cover crops are really good at it. They are determined to go down, and they'll go around a rock. if the soil is dry, they can't get through the hard pan. They'll grow along the edge of the hard pan, just looking for a spot where they can go down. So they really like that. They need to be tolerant of hypoxia. Of course, one of the big problems with the hard pan is that the water doesn't drain through it very well. And when you have water collecting on top of that, it's very depleted in oxygen. And so you need a root system that will move some oxygen through the root down to the tip of the root. And it's very helpful to have one that the tip of the root is narrow, but then the root grows radially. So some root systems, they come through with a small root. The fibrous root systems are typical for this. They put out a lot of roots, but the individual roots don't get much bigger once they've been put in place. So the upper part of the radish, of course, is the extreme example of where you have a tiny little root that ultimately gets to 2.5 inches wide. We don't need them to get that big. We're trying to make macropores. A few millimeters is enough, but where they can squeeze through a tiny little hole and then widen it. And those little holes, again, they may have been made by a worm or a beetle or a fibrous root from a previous cover crop. We like them to grow for a long time so that they can keep working down deep. It takes a while for the roots to get down to where the hard pan is. So if we have a cover crop that we're planting in September, it will probably get down to the hard pan in the fall, but then it doesn't really have a lot of growing time to do the work for penetrating. And it needs to grow then in the cool weather when the soil is softer. Generally that subsurface layer is pretty hard and dry during the warmer part of the year in this climate. So this time of year in the fall, it doesn't dry up as quickly. The soil down there tends to be mellowed somewhat from the biological activity of the growing season, and then is a little bit wetter, and so the root has a better chance of going through it. And I like the brassica cover crops for this role. They do it very well. They do need to be planted in roughly the middle of August, or possibly into late August to really do a good job of that. And then the other part of biological interaction, a lot of the time when you pull these cover crops up out of the ground, see how deep they're growing, you find lots and lots of worms right there in the roots. Well, the worms are great helpers, and they will also help push down and perforate that subsurface hardness. So these are some of the interactions that cover crops will be doing for you. So teaming that up with the deep zone tillage that's that just makes the specific slots is a good way to go.
What's that something word that you use there? I'm not familiar with that, and probably a lot of others aren't.
Which, the deep zone tillage?
You had worm something.
Oh, that's because I don't type very well. Oh. Worm supporting, sorry. Yeah. And so this is a picture of what it looks like. So I've been using a field at the research farm where we've grown vegetables now for about 75 years in a row. And it's a great honey oil soil, but this 75 years of beating on it has left it in less than optimal condition. And so I took a sample out where we had not tilled, and one where we'd allowed the roots and the worms to develop. And you can see that there's quite a few holes. There's some little roots growing out of what looks like no hole at all. So they're starting to make the little passages that can be enlarged. Something like this has very much the look of a worm tunnel. And worms build houses in here. So if you till it up, you kill all the worms and destroy their houses. So that sets you back on the worm front. So leaving this intact when you can, and having the tillage, if you will, done by the cover crops and the worms is good. So here's our good old buddy, the big radish. And so some of the activity is this upper root, but um, there we go. Um, the whole radish doesn't go in the ground. So if you're not familiar with the radishes yet, yes, those roots get big and long, but the really fat part, 3 inches deep in the ground is pretty normal. It's not, they don't usually go much deeper than that for that really big fat part. So while it's dramatic, that's not where the action is. But you see that the roots coming down below it are pretty fat for a root. They're plenty fat for penetrating and making valuable holes in the untilled and in the deeper layers of the soil. So that's where the action is. These other roots, and there's more of them, are actually doing a really nice job. And again, to have them really do that job well, you need the radishes to, the individual plants need to get big. And so you need a relatively low seeding rate so that they don't crowd each other and cause them to be smaller. You need to plant early enough that they have time to get big. And you need to have enough fertility that they'll get big. So that there's some requirements to having the radishes live up to their potential, but they can do that. That also means that some of the other brassicas, which also make the fatter small roots, work very, very well. So you don't have to have the big fat part. It's been helpful for marketing them, very, very much so. But you can get a lot of those subsurface benefits without it. Here's another pair to go over to the grasses. So you think when you look at month-old stand of millet and a month-old stand of sorghum Sudan grass, you'd be hard-pressed to tell a difference. They look almost identical above ground. But when you look below ground, there's a substantial difference. So the millet has a very fine root system, great for stabilizing the aggregates, but that's not going to punch through a compacted layer of subsurface hardness. The sorghum Sudan grass, on the other hand, has much stouter roots. So if you want to be perforating a hard layer in the soil, that's your cover crop. So it actually makes a big difference which of these two otherwise similar cover crops you would use. So being aware of that difference is really helpful. All right, so that's using cover crops to avoid one of the most soil health destructive tillage practices. So now we're going to go into the area of supporting the soil biology. And so we'll start with the protein part of it, and just sort of to put it in context. So I'm going to be talking about the active carbon, the respiration, and the soil protein. So if we think of the tractor as a metaphor for our soil, the active carbon is how much gas you have in the tank. The respiration is how fast the motor is running. And the soil protein is how big the motor is. So I think of that analogy. So they're doing complementary things. If you want to really pull that plow, no, you don't. You don't want to pull that plow at all. But if you really want the tractor to really do a lot of work, you need to have all of those things happening at the same time. So if you're running an undersized tractor, pressing the throttle isn't going to help move you faster. Filling up the gas tank isn't going to help you go faster. If you run out of gas, doesn't matter how big the engine is. So you need all of those things there. So if you'll allow me that analogy, that might put some of these other things in good context. So the increasing the protein, this is your organic nitrogen. It is all of the protein that makes the microbes go, all of the enzymes. And we have two main ways that we can get organic nitrogen into the soil. One is by fixing nitrogen from the atmosphere, using legumes. And the other is scavenging nitrogen that would otherwise be lost to leaching. And typically we do that with the crucifers. And depending on the production system, one tends to be a more obvious choice than the other, but it's very system specific which one. But we have two different approaches, and both of them work just fine. And the key is to kill them when they're very green. You want to have a net nitrogen gain in the soil. So you hear about the carbon nitrogen ratio of 20 being good for a break even. That's a nice balanced carbon nitrogen amount. But if you're trying to build the nitrogen, you need more nitrogen. So you're looking at 6 to 10, and that's when the cover crop looks the way it does in this picture. Very, very green. Basically, you're talking green leaves, not a lot of stem to get numbers like that. So this is the cover crop. So really a short-term cover crop for the most part. With the we have some legumes that are really good at growing during the month of May. So with those, you can incorporate those towards the end of May and get quite a lot of nitrogen from a higher volume in a longer period. But otherwise, a lot of these are fairly short term before they've produced too much stem. Then the active carbon. So this is the food that will provide the energy for the microbes in the soil. So the first, with the carbon balance, you have to be adding more carbon with your cover crop than is used in growing the cover crop. And of course, that naughty plow that I showed a couple of slides back is a great way to use up the carbon in the soil. That really oxidizes a lot of the soil carbon. So if you're plowing in order to plant the cover crop, you're probably going backwards on the active carbon. It is the active carbon that is oxidized first when you're tilling also. But then looking at the cover crop when you're incorporating it, you want moderately complex carbohydrates. So you want mature tissue that's going to last a while in the soil. Those really green cover crops I showed for the building organic nitrogen, they're going to decompose very quickly. They're low in carbon, that carbon's going to be used up right away. So if you're building active carbons, you want something that's more complex. It's not going to be digested quite so quickly. And woody tissue, of course, takes a long time, and it's essentially inert for this purpose. It's not active carbon, it's inactive carbon because the microbes really can't get at it. You also need to think about the particle size and chopping things up too small isn't generally a problem because it's too much work. But the pieces of cover crop residue need to be the right size for the microbes to be able to get at them. I think everybody's had the experience of big crowns of sometimes corn, but Sudan grass is a good one for it. Annual ryegrass will make nice big clumps. Basically, the microbes can't get at the middle of the thing, so they take a long time to break down. So you want ones that are smaller than that, but basically available for the microbes to consume. And to stretch out how long it lasts, having these be what's called protected residue, that puts them inside the aggregates. And so incorporating gently. So one of the things with rototilling, which is a technique that's used by gardeners for incorporating cover crops, if you overdo that, particularly if the soil is dry, you break up the aggregates. And so none of the carbon is protected in aggregates. And then it doesn't last very long. And roots are really good. So again, if you can remember back to the picture of the buckwheat root, it was right in the middle of an aggregate. It's good protected residue right there. It grew itself. It took no work on the grower's part, no steel involved. The roots made aggregates around them, and then they die, and then they are protected organic matter. So roots are a great source of active carbon. And then we have the soil respiration. So this is basically how much are the microbes doing? And so you want to build up a fairly large population of the good guys. And I've been on our soil microbiologists for a long time saying, give me an assay that lets me see whether my practices are resulting in more good guys or less good guys. Am I moving in the right direction? And we're not there yet. So I really want that assay badly, but to see how we're doing and can get a better analysis of whether we're building soil respiration with the right components. And yeah, we'll keep at it. It's an important goal. Oops, sorry, there we go. But so to do this, we want to make sure there's active carbons for the soil microbes to eat. So putting in a lot of biomass every year, and you can do that through live roots. So having I'm sure everybody's heard, try to have live roots there for as much of the year as possible. And this is a large part of what they're doing, is feeding those microbes. If you don't have the live roots, they starve because there's nothing for them to eat, right? So the ones that are dependent on the root secretions. So keeping that up keeps that population high so that they'll work when you need them. And then the proteins, so the respiratory enzymes that the microbes are using, they are proteins. They need that nitrogen that comes from the soil organic nitrogen. And again, limiting the amount of tillage, because they live in particular structures in the soil. So they like to be in a certain part of the aggregate. They like to have a certain amount of micro and what do you call them? The spaces. I'm so stuck on aggregates. Forgetting the word of the hole between them.
Micropores.
Thank you. And then you have to have oxygen in the soil. So that's where having good soil structure that allows oxygen to come in. I mean, imagine you have the soil as a spongy thing that's generating lots and lots of CO2 through respiration. You have high CO2 levels in all the pores. Then the oxygen is supposed to diffuse in from outside at the same amount as the CO2 coming out. It really takes a really good porous structure to be able to have enough oxygen penetration down through that whole soil profile where you want this activity going on. So with the soil health tests, a lot of the prescription for particular deficits, where you're getting red colors on the reports, one, it says to reduce tillage, and two, it says to use more cover crops. That's often the prescription. So, thinking about how do you do those, and it is the right answer a lot of the time, no doubt about it. One of the things I've found, both in my own work with cover crops and just looking at the literature, is that you have to reduce tillage first. That the cover crops really don't do very much unless you've also reduced tillage. One of the questions I started off with was, how much cover crop does it take to compensate for having fall plowed? And as far as I can tell, there is no amount of cover crop that will come close. So reducing tillage is really very important. And I've been doing that on my research farm, so that we're using deep zone tillage for everything. And it's way, way better. The cover crops do more. I can tell you that so this field that was in terrible shape 3 years ago, we've continued to till for certain experiments in half the field and have done deep zone tillage on the other half. And the cover crops I planted this fall on the parts that did not have the tillage, that have had just deep zone tillage, they're twice as big. And not just in the deep zone till all the way across the field. They're twice as big. They grow great. I can walk in the field fairly soon after it's walked. The other is a muddy mess. So the reducing tillage really lets the cover crops do their job. We've got that block of untilled soil in between the zones, and that's where those roots are growing, where the worms are working, and we have beetles and springtails and all kinds of interesting squirmy things in between there. So we've got lots of biology going in there, and using roots, we keep pumping more organic matter into those. But those two things are not separate. They really work together. So the reducing tillage, you're preserving aggregates, you're preserving organic matter when you're reducing tillage. And the cover crops then are adding organic matter, they're adding nitrogen, they're adding glues to form the aggregates, and then they give you live roots during the non-cash crop part of the season. So those are some of the direct benefits that you're getting through each of those components of the prescription. So I've put the decision tool to help think through some of these things and identify which exact cover crop will do this. So I've mentioned a few cover crops in this talk, but not in a way that is super helpful in deciding which one you want for a particular situation. But I developed this because people would say, well, I need to use a cover crop now. What should I use? And I don't have a lot of time to think about it. So we developed a tool where the idea was, you tell me what you need to do and when you're going to do it, and we'll give you some choices, some easy choices that you can choose among quickly. The amount of resources that have developed from other places in the meantime is fantastic. So you have lots of choices. I think when I first started this, Rod Porter wasn't working for King's Agri-Seeds yet. So even resources like asking Rod what you should do weren't available. So like I said, things have improved a lot. But this is still a widely used tool. I can keep track of how many people use it. And it's running around between 60 and 100 searches per day year round still. So people use it quite a bit. And the idea is you put in your management goal, it gives you some ideas and then tells you how to plant them and what to avoid. And then I'm going to just finish up with this so we have time for a few questions. I just want to reinforce this on cover crops every single time I talk about cover crops, that to get the value out of the cover crop, to have success with a cover crop, you have to do three things that every farmer knows how to do. You have to get them off to a fast start. So all the things that makes a seed germinate quickly, do those things. Good seed soil contact. That was one of the last things Rod said in the video. Good soil moisture, warm soil, all of that stuff. Good quality seed. Then not having any gaps in the stand. So that's been a huge problem with cover crops because people get sloppy. And when you get sloppy, you leave gaps. If you're rushing through with broadcasting and you're not overlapping the bands enough, lots of gaps. You get nothing but weeds in those, big problems. So no gaps, every farmer knows how to do that. And then kill on time. So cover crops do what you need them to do at a very specific time, and they become a problem if they're too old. So if you're planting a cover crop, you should know how and when that cover crop is going to die. There should be no question in your mind when that seed goes in the ground, how it's going to die. So that's my little universal pitch on how to have success in cover crops. And with that, I think we have a few minutes for people who have ideas on these topics.
We got about 5 minutes for questions. And Thomas is a great resource for any cover crop, vegetable systems particularly, but cover crop questions in general.
So are some of the things I talked about more difficult to implement?
I had a quick question, if I may, on the implementation. I haven't researched fully the tool you've showed us on the covercrop.org. I was wondering some of the options we have when implementing any of these is dependent upon the machinery, the equipment.
Yes, yes.
Is the tool you have constrained for that, or I mean,
Yeah, yeah, no, that's a common need. And so what we did is that when you put in sort of your primary goal, what's a primary management goal that you have, it will provide several cover crops that will fit that for the season that you're interested in. And it has in there how to plant it, how to kill it, that sort of thing, to help decide whether it's something that you can actually do on your farm. Gives a sense of how much it costs, what kind of diseases it may help promote. So if you're growing particular crops, you might want to be extra sensitive to certain diseases. So it has those things that that help you decide quickly whether it's something that you can't do because you don't have the right conditions for it. So yeah, absolutely. That's a very important thing to know about a particular cover crop system.
I have a quick question, please. Hi, Jennifer Phillips Russo. I actually work in viticulture, so I'm working in perennial systems, and we are putting together some cover cropping trials where we're trying to.
Yes.
We have a side discharge mower, so we want to
Yes.
mow and throw under the vines to conserve water. I can't get anything to grow enough biomass to do that, and we've used cereal rye, we've used cereal oats.
Right.
Can you suggest some things?
So are your row metals otherwise in a perennial grass?
We have a mix, usually of a brassica and a legume and a grass.
Okay. Yeah, and you don't want them to grow too much because then they're interfere with the grapes.
Right. We have to terminate by bloom, which is right around June 10th.
Yeah. Yeah. No, it's hard enough to get enough volume to fill that up. There's some work going on with under vine cover crops.
Justine?
Yeah, and I was involved with some of that. And the one that really looks interesting is chicory, which is kind of an unusual one that you don't think about very much, but it's a rosette, which makes it not grow up into the grape canopy. And when you hill up the vines, it gets killed. It also makes a nice taproot for the subsurface penetration. We tried some of the legumes there in an experiment. And that ended up being our bare ground one because the woodchucks came in and ate it all. So that sounded good, but that was a constraint we had not accounted for.
Okay, thank you. I'll look into it.
Zone tillage might be new for some people, so maybe, I don't know if you have a picture around, but maybe it'd be worth just throwing up a picture of.
Oh, do I have a picture of our?
I could throw it up from the internet.
You probably have one, yeah. So please throw that up. Cool.
So I know a lot of what we're doing is really in support of ag, but one of the things that I know I do, and Marcy, you also do this, is we support a lot of home gardeners as well.
Yes.
So I do both. And so, you know, when we tell home gardeners, if you really want to kind of level up, start doing cover crops.
Yes.
So I'm trying to think of, you know, what's the easiest entry level cover crop on that scale? Usually I recommend something like crimson clover because it's both beautiful and people love it and it's
Yes.
pretty easy. But
Yeah.
I'm wondering if there's something else that might be a good
Yeah, so
entry level.
and the crimson clover is good. It's a little bit slow to establish. I find that in the summertime, buckwheat is a good one because it grows very fast. It's really easy to sow. You can do it on 3 square feet at a time if that's the space you have in a raised bed. It looks beautiful. It grows very, very quickly. So I know some really hardened, cynical farmers who raise buckwheat mainly because they love watching it grow. They don't make money at it. It's an okay rotation crop for them. They just love watching how it grows. So that's a good one. And what that allows them to do is have areas that they've harvested that they're not planting, that they don't grow up into weeds. So it saves them a lot of weeding time. That's what really is the value there. And then
Buckwheat seed.
the winter, having a winter grain is good. If it's available, I like triticale a little bit better than rye. It doesn't get quite as tall and it's a little bit more robust. In the plant habit is more robust. The rye tends to be thinner. But oats is also nice for a fall one, and it dies over the winter mostly for us. So it's the kill on time aspect gets taken care of. It doesn't require the gardener's attention during the off season. So that's a little bit of a plus on that one.
Didn't buckwheat seed, it used to be controlled, like who could buy it, who could grow it? It's not that way anymore?
Buckwheat cover crop seed is widely available. If you want to grow it as a food and sell it to the, well, Burkett Mills in this area is the only company, but they use a variety that they have the rights to, but nobody else does.
Okay, all right.
So they're not allowed by the owner of the seed
Right.
to sell that independently, but there's lots of cover crop seed available. So that's not really an issue.
And there's a pink flowering variety that's actually just really gorgeous. And you see pictures of hillsides just covered in it, and it's pretty spectacular.
Yeah, the Asian ones
Yeah.
tend to be pink, and there's an area in Korea where they saw that the cherry blossom festival was so popular in Japan as a tourist attraction that they decided to go for the same thing in this one province of Korea and have the buckwheat bloom, which comes about 2 months after the cherry blossom. So they tried to get the same tourist thing going with the pink, same color flowers, just a different size plant. But it is gorgeous. It can enough to start a tourist industry.
The only one thing that I see here in Long Island with the buckwheat is that because it goes to seed, it grows so fast and it goes to seed really quickly. If you don't
Yes,
kill
it
it
does.
on time,
Yes.
then you will have issues later. So if you
Yeah.
use it for cover crops, then for Mila, I know you were asking, the person, whoever uses for cover crops has to terminate it on time.
Yeah,
If you
and
don't
that
want it,
is that, and basically that's 35 days is when you want to do that. So you can put it on the calendar when you plant, so you know when to kill on time. It's right there on the calendar. But the other clue is that it becomes completely covered in white flowers. So if you notice that it's changed, the field or the planting has changed from green to white, that means it's time to kill it. It's hard, if you look, it's hard to miss, but if you're not there to look, it needs to be on the calendar.
So if you had a small garden, you could just like maybe run a weed eater through and knock all the flowers off and let it die on its own.
You actually have to cut it pretty low for it to actually die.
Okay. Okay.
But it kills very easily.
Okay.
And
yeah.
even if you do get seedlings, they kill very easily. When they're small, they cultivate out no problem. So organic growers don't have a problem with that. And the
I've had